Hey folks, welcome to my channel Number Pen. So there we have the problem on the screen. Integrate the following with respect to x. We have log x the whole divided by 1 plus log x the whole square. Right? So what we've been given is dy by dx and we've been asked to find y. My y is nothing but integral of the given expression. So let's write down what our y is. That's my y. And I know that my y doesn't seem to be in a very simple format whose antiderivative I know from first principles, and it doesn't seem to be in a very simple UDV format either. So can I solve this by the method of substitution? So let's try that out. And the substitution that I can make out here is t equals log x, right? I cannot think of any other substitution. And let's see how to go about solving this particular problem, right? Now, my dt becomes equal to dx by x, right? And then I know that when my t equals log x, my x equals e to the power t, right? Now let me go back to my y and then rewrite everything in terms of t. So my log x is nothing but t. I'm at the numerator right now. And my dx is nothing but x times dt, which means I will have an e to the power t dt, right? I hope you folks are with me. Let me also write it down here. So my dt equals dx by x, right? So my dx equals x times dt, which is nothing but e to the power t dt. That's my dx, and let's come down to the denominator, and I have a 1 plus t the whole square. I still don't think it's in a very simple format, but what have we done? What we have done is using the substitution t equals log x, I have brought an e to the power t expression in my numerator, right? So this is what I have, integral of e to the power t times t dt divided by 1 plus t the whole square, right? I'm not going to touch my e to the power t for a minute. And can I alter the t dt by 1 plus t the whole square expression? The answer is yes, I can do that. I rewrite that particular expression as t plus 1 minus 1 the whole divided by 1 plus t square, right? Right, now let's go to the next line. It's getting very clumsy out there. So I decompose this further, right? And how do I do the decomposition here? I have my e to the power t. And all that we are trying to do, again, I'm repeating, I'm trying to express this of the form e to the power t times f of t plus f dashed of t dt, right? So when I decompose this, what do I get? My first expression, I do a t plus 1 divided by 1 plus t the whole square. And what I get is a 1 by 1 plus t, right? I hope you folks are with me. And then I move to the second part. I have a minus 1 divided by 1 plus t the whole square. This is the expression what we have. And I know that I'm in a position right now to connect 1 by 1 plus t with minus 1 by 1 plus t the whole square, right? And you folks know why is that? Because d by dx of 1 by 1 plus t is nothing but a minus 1 by 1 plus t the whole square, right? And I expect all of you folks to know this from our first principles in differential calculus. So I have been able to reduce this to the format y equals integral of e to the power t. I'm not going to solve this further for you, and I request you to take a look at some of my previous videos where I've solved problems of very similar type. Okay, so we have e to the power t times f of t plus f dash of t dt, right? So the key here is reducing this particular expression what we started off with, right? Log x divided by 1 plus log x the whole square to a format e to the power t times f of t plus f dash of t dt, right? Which makes it a lot more simpler for us to arrive at what is our y. My y is nothing but e to the power t f of t. And what is my f of t out here? My f of t is nothing but 1 by 1 plus t, right? So my answer is e to the power t times 1 by 1 plus t. And I know that I cannot leave my answer in terms of x, right? So I will have to simplify this further. My e to the power t is nothing but x, and then my 1 by 1 plus t is nothing but 1 plus my t is a log x, right? So I have x divided by 1 plus log x, and I have my arbitrary constant c, right? So my answer to this problem is x divided by 1 plus log x plus c, right? So let me highlight my final answer in pink. There we are. I hope you found my content useful. Please do subscribe to my channel and support. Thank you.